For 0.4, we're looking at inverses of graphs. So there's a couple of things that we want to keep in mind, and I would add them to your notes. So if f of x is the inverse of g of x, the following things are true. 1. The domain of f of x is the range of g of x. 2. The range of f of x is the domain of g of x. So essentially our domain and range are switching for inverses. And if xy is a point on f of x, then the point yx is on g of x. So that means our x and y coordinates are switching when we go from our original function to our inverse. So that is going to help us finding the inverse of a graph. So to find the inverse on a graph, you want to pick a few key points and switch the x and y and graph those points. So when I look at my graph, I have this point here at -3, -1. This point at 0, at 0, 1, and this point at 5, 3. So my inverse points would be switching those. So -1, -3, 1, 0, and 3, 5. So just to see what my inverse is looking like, there would be -1, -3, 0, 1, 0, and then 3, 5. And I'm actually going to do this point. That point's at -4, -3. So it would be at -3, -4. So this is what our inverse graph looks like. So here's the next example. I want you to identify your key points and then say what your inverted points would be. So some of those key points: 0, 1, 1, 2, 4, 4. So when we invert them, we would have 1, 0, 2, 1, and 4, 4. They would share this point. Oh, whoops, that point is here. So I want you all to try finding the key points yourself and then inverting them to find the inverse. So some of these key points, we have 0, 1, 1, 2, and 2, 4. So our inverted points would be 1, 0, which would be here, 2, 1, which would be here, and 4, 2, which would be here. And then our graph would look something like maybe a little bit more like this, similar to what that original function is doing, hugging instead of the x-axis, the y-axis. And then you could always check to make sure your domain and range are in fact switched